Remember, say for instance, if you have two number, A is equal to 10 and B is equal to 20, let's say C is equal to A plus B. Let's say C is equal to A plus B. Alright. Now, how we were printing them? We are printing them in this fashion. Print the value of, say, addition of, then plus A plus and plus B plus equal to plus C. Okay, so when we execute this is string of A, string of B and string of C. String of B and string of C. Now, this is not a very elegant way of doing it. We might have several variables, we might have several things to print. For that, Python provides an exceptional way of handling such formatting. Now, the same thing we could format it simply in this fashion. Let's say the string that we want to display is str is equal to, will print the entire statement, the value of addition of. Now wherever you want to print a variable, just give a number in curly braces, 0 and 1 is equal to 2. Close the string, dot format, 0th value is nothing but A, first value is nothing but B, and second value is nothing but C. So you want to print the value of addition of whatever value you have specified for A, whatever value you have specified for B, and whatever value you have specified for C. All right. Now, let us remove this statement entirely and replace it with just a variable. Because string is a keyword, let us give it a name called S. Let's print S. Now, the value of addition of 10 and 20 is equal to 30. You don't have to keep on writing those plus, colon. You don't have to remember. This is a wonderful way of writing this. Now, sometimes we might even have the option, we might even have different variables, many number of variables, and it is extremely difficult to remember them with 0, 1, 2, 3, 4, so and so. So instead of doing that, you can actually specify a name over here. Say for example, let's put a comment here and let's put the string, the value of addition of, say, variable underscore A and variable underscore B. You can give any name, is variable underscore C dot format. So in there, all you have to do is variable underscore A equal to your A variable, variable underscore B equal to your B variable, and variable underscore C equal to your C variable. So wherever your number of variables are more and you find it quite complicated to remember it with 0, 1, 2, 3, 4 such names, you can adopt this format also. Okay. Now let us see one more example of how we can use it. Let's say that we want to represent the data of a student with two fields, name and age. Okay, so we can write it in this fashion. Age is equal to std, say let's say age is equal to name equal to std underscore, in curly braces, std underscore name, and age is equal to std underscore age, double quotation close, dot format std underscore name equal to Rupam, comma std underscore age equal to say 36. Now one thing that you can see from this format is that we don't have to convert everything into string. We can keep the data type as it is and still it is going to take the format. For example, here student name is a string type and age is an integer variable. It's going to take both the types. All right. Now let's print it. Print the value of age. Name equal to Rupam, age is equal to 36. Now, Python also allows you to format how you are going to display the value. Okay. So for example, if after name I want some spaces, what I have to do over here is I have to give the spaces in this pattern. If after age I want to have some spaces, I need to give those spaces in this pattern. Now if I execute them, after name there will be a gap, after age there will be a gap. But this is again not a very elegant way of doing, because you might have to change your formatting or number of blank character depending upon where you are displaying. In HTML page you might have to format it differently, in a Qt or other GUI pattern you might have to do differently. So what it allows us to do is it allows us to also specify the format. Like if you just specify after student name, if you specify say for example 0, okay, sorry, for example 5, okay, and student age colon 5. Under that situation, after student name there will be a space of 5 characters, and after age there will be a space of 5 characters. Let us execute this. Now you see name, Rupam, age, after that there is 5 characters. Now why you can see the 5 characters over here and 5 characters you do not see here is that this is left aligned. Okay. Now let us give 15 characters and see how it works. Okay, so after Rupam there is a 15 character gap, then there is an age, let's give it 35. After Rupam 35 character gap, then there is an age. If you specify 0, immediately age will come. Okay, now let's give both 1 1. Now I want age to be displayed on the right side. Okay, this is by default left alignment. I can also specify the alignment operator. I can specify so after colon, if I specify only characters, the name will appear, I mean after Rupam, it will appear after 36 character. Now over here, if I specify right, greater than sign, then it is going to be right aligned automatically. So the alignment will be on the right side, okay? And if I write 0 or say 4 characters, this is going to be right aligned by 4 characters. So name equal to Rupam, and then even age, you can align it on the right. So both right side and left side alignment can be done accordingly, okay? Just by specifying number of, after the variable, just by specifying the value, you can specify this. Now, this is also not a very elegant way of doing, because many a number of times, making the changes in the code is not really advisable. So what we might do is we might specify the whole formatting as a variable itself. Say, for example, name underscore width, let's say its value is 10, and age underscore width, let's say its value is 20. Now, because I have declared a variable, instead of specifying this to every statement, I can actually use the variable name. Instead of 4, what you can do here is you can just specify, say, in width, in curly braces, age, colon, in another curly braces, age width, student name, student age. Along with that, you can specify NW is equal to name width, and AW is equal to age width. Then both of them will be formatted by 10 characters. It has got the same effect, okay? 20 characters. Instead of 20, if I just change it over here, you see this is formatted. So I'm not required to make the changes in the code. Instead of specifying a name, you can also specify them in this format, 0 and 1. If you specify them as 0 and 1, here you don't have to specify NW and AW. You can write them in sequence order. So by default, this is going to take the name width, and this is going to take the age width. If you specify it in this fashion, this is going to give you an error that positional argument follows the keyword argument. Because you see, you have specified 0 and 1 over here. So in the format specification, they should be in the 0 and first position. And if you have mixed up keywords, for instance, here I have used keyword student underscore name. Here I have used the keyword student underscore age. So, and along with that, for formatting, I have used argument 0 and 1. So because of this, the argument 0 and 1 should be 0th and first argument in the format specification. So whenever you have a combination of numbers and keywords in the format statement, you need to specify it in this fashion. So now you might use the student name and age at many different places in your program. You don't have to, in a large production program, there might be hundreds of lines of code which might be using the formatting. So instead of keep on changing in each line, now if I make a simple change, under that situation, I can just put them aside, okay? So I don't have to just change the code. Now, Python's formatting is also very important for number conversion. Python gives a lot of good ways of representing your numbers also. For example, let's see how to format numbers. See, formatting numbers. Let's say that I have a variable called b is equal to 1e minus 3. This is nothing but 0.001. Many a number of times while doing the actual processing, we might deal with the exponential number and so, but sometimes we might require to print them in their actual format. So it allows you to print it how s is equal to zero colon g dot format b and let's say print s. Sorry. You see, it is printing 0.001. Now 0 is the 0th argument, okay, and colon. After colon, we have learnt in the format specification, after colon, whatever you specify, that is the display formatting, okay. So here I have given general pattern. So 0th argument should be displayed in the general pattern. So it's going to display it in 0.001. Now you can also specify in this fashion. Var underscore b should be specified as a general pattern. So format var b equal to b. Okay. Now if I want to specify it, if I want to display it as it is, I can simply remove this. It's going to print in its own format. But you see, if I have to display it as, for example, the exponential itself, I can just specify colon e. Then this is going to be printed. Purely as an exponential number. You see, 1.0000 so and so into 10 to the power minus 3. That is nothing but 1.0 into 10 to the power minus 3. So in this way, Python can, you can format a number into string. On the other hand, say for example, if b is a number, say for example 0.2370097, I can also represent it in the exponentials. 2.37 into 10 to the power minus 1. So you don't have to every time think about, keep on adding this string. You can use this in order to convert them into string. But the thing to be remembered is, after the formatting, s becomes a string. Okay, after you have used string dot format, the result is also a string. Okay, that is not a number anymore. So after this, if you try to add something, say for example 10 or something, this is going to give you an error that cannot convert int object to string implicitly, which means that the result of the format operation is also a string. Now if you want to perform certain operation on that, you can just convert back that string into float and long. Okay, now you can perform the operation. Now, so far we have seen how numbers can be converted into string, how number can be added with a statement, how string, number and different types can be added with a statement. Now, sometimes it becomes also necessary for us to convert the what do you call string into a number. For example, let's say conversion of string to a number. In many of the cases, Python is used for real-time processing, where data might be in the text file or might be in the Excel sheet, where the data will be present as a string. You might read the data as a string, and then for any operation you need to convert them into integer. So let's say that I have a string whose value is 12.77, which has been read from either Excel sheet or some file or some data set, something. Now what we cannot do is we cannot write a is equal to s plus, say, s plus 20. We cannot do that simply because s is a string over here, and if we try to print the value of a, it's going to give an error that integer cannot be implicitly converted. So what you can do is, if the value is a float variable, simply you can convert it into a float and it's going to show the result. Okay, you can also convert it as integer. So my value is 12.77. If you convert it into integer, this is going to give an error saying that this cannot be converted because this number specifically is not an integer. You can round them off. You see, so 12.77, it cannot convert it into integer. Now, whenever you have such cases, if you want to convert any string into, say, integer, you need to first convert them into float. Okay, so you need to convert them into float, and that float you have to convert it as integer. You see, the result is 32. Okay, because once you convert a float into integer, the decimal points are completely omitted. Now sometimes we might require to consider 12.77 as, say, 13, and anything below 12.5 as 12. We call this operation which you are seeing is known as the rounding off operation. There are two ways how decimal is converted or float number can be converted into integer. The first method is called rounding off, whereby if you are using directly int command, any float variable will by default leave out whatever is there after the decimal. This operation is known as round off operation. There is one more operation which is called ceil operation, C-E-I-L, ceil operation, where anything above 0.5 will be considered as the next highest number. However, for sealing you need to use a mathematical package. Let's say import numpy as np, and then you can use a sealing statement. So instead of converting it, before converting it into integer, you can just use np.ceil. You see, it is printing 33 because ceil operation, as it is 12.77, is going to convert it into 13 and going to print it. Now, why do we require to give an integer command? Because ceil will anyways convert it into 13, right? So what if I remove this integer from here? If I remove integer from here and if I only use ceil, the ceil actually converts it into a float of the next number. So you can see it becomes 33.0. Okay, 33.0. So np.ceil also produces a float number by just converting it into an appropriate integer corresponding number. So the difference is in rounding off process, and again you can also take np.round. If you take np.round, under that situation, actually should have taken it as the 32 only. I do not know what is the problem, but rounding up should have converted it into what do you call 32 only. Okay. Now in np.round operation, if you do not specify any argument, by default this is going to take as the hand number. On the other hand, you can round off this to 2 or 1 decimal places. For example, if the number is, for example, something like this. Now after you have used 2 in the round off operation, this is going to take 12.77 only. So 12.77 plus 10 plus 20 is going to be 32.77. Instead of 2, if I use 4, 7798, it's going to take up to 7798 and round off the other part. So using np.ceil you can get the higher number, using np.round you can get the lower number, and if you want to completely strip everything, if you specify np.round 0, this is going to act just like a ceil operation only. And if you want to convert it into integer, after performing this operation, that is, you can just convert it into integer. So while converting it into integer, because you have already got 22, the result is going to be 32. So this is how we can convert a number, convert a string into integer, convert a string into float, convert a float back into an integer. But Python doesn't stop here. It provides much better conversion. For example, in many scientific calculation, we might have to convert the number system. For example, decimal to hexadecimal or hexadecimal to binary, so and so, so and so. Now, conversion of hexadecimal number to integer number and vice versa is a lot of pain in most of the programming languages, but in Python that's extremely simple. So let's say how we can convert between the numbers. Convert between the numbers. Let's say I have a binary number, say b is equal to, let's specify it as a string 0b. 0b stands for a binary number, 1101, that is nothing but 13, right? Yeah. Okay, now if I want to see its integer equivalent, say I is equal to int of b, and let's print. Now we know how to format it. I is equal to 0. So we are not going to use those earlier pattern anymore. Dot format. Let's specify the value of I. So either you can declare it as a separate string and then print it, or inside the print statement also you can develop the string. So for such formatting, because this is a binary number, its base is 2. So if you take base 2 along with integer, when you specify a string, this is going to be converted into a specific decimal number. For example, if I take an hexadecimal number, let's say h is equal to say hexadecimal number we generally specify with 0x extension. Suppose my number is 1e. This is a hexadecimal number. Hexadecimal number has base 16. Let us specify base 16. I value is, it should show 30. There is I. Oh, sorry, h. I need to specify h here. Let's see the calculation. If I specify hexadecimal number 1e, this is going to be decimal 30. Let's say if I take hexadecimal number f, this is corresponding to 15, right? 0 to 15. This is going to print 15. If I take 11, that is 1 1, hexadecimal 1 1, the value is 17. You can check this. Let's take hexadecimal. In decimal, this is going to be 17. So this is how easy Python makes it for you to convert between different patterns. Now there is one more significant thing. We have already learned how you can use NP to round off a number. Now for a very high precision scientific calculation, the decimal points are significantly important. For example, if you are calculating in terms of some space related calculation or a very high precision calculation, rounding off is never a good option, right? You might have a number which might be having a precision of up to 17 decimal places, 18 different decimal places. Any change, any small change in those number becomes extremely difficult. So it's never a good idea to rounding up the values. But always, if the number is, say, for example, 17 point, see, for instance, the value of pi, okay? Let's say if I print the value of pi, print string of np dot pi. If we run this, you see the pi value is 3.1415. Now I can always round it off to 3.14, but in a cumulative term, in a very precision scientific calculation, such rounding off will result in lot of errors because the pi value is quite long, quite high precision value. So if I say use np dot round of np dot pi up to 2 decimal places, definitely this is going to show me 3.14. np dot round np dot round. This is going to show 3.14. Now let us multiply this with a huge number. Okay, for example 1.772348, right? Now if we do that, the result it is showing is 5.56, and if I do not use np dot round, see the result 5.56. If I do not use this, if I do not use the rounding off, the result is 5.567. Earlier it was 0.565. So 0.002's difference it is. However, see, if the number is so large, sometimes printing them with lot of other result becomes very difficult, because for observation you might not require the entire precision value. You require the precision value for calculation, but for display you may not require that precision value. So what you can do is, you can make the calculation. Let us say that this is my calculation. Let's say calculation is equal to this value. So here I am not using any rounding off, but at the time of displaying, you can zero column 0.3f dot format calculation. Calculation is the variable. So if you do in this fashion, let us also print calculation, so that we know the difference between both of them. See, here my calculation value is this much only, 5.5678 so and so. Now I have used 0.3f, which means that this is going to present only up to 3 decimal places. However, there is no change in the actual value of the calculation. That value remains same. So for all the scientific calculation, you may not want to do a rounding off or sealing off the value. You may calculate it as it is, but at the time of displaying, whatever is your format, you can format it accordingly. 0.3f means how many decimal places you want to display after this. And how nicely it has done is, you see, first 2 points it has kept as it is, because it has to trim the rest of the things after third decimal places. It has rounded off the remaining of the things at the time of display. Similarly, you can say 0.1f. So it is going to show you 5.6. Why 5.6? Because more than 1, okay, the rest of the values is going to be formatted into 5.6. If you had taken 2 decimal places, if you had taken 2 decimal places, it's going to display up to 5.7, okay, because 5.6 and after that this value was. Now if I consider the value was 5.56095 so and so, 095 so and so, under that situation it would have shown 5.6 itself, because 095 so and so would have got formatted as 0 only. So this is how you can use the format operations in Python to convert from one specific data type into another specific data type and display the value. Just as you have converted let's declare something like 101. This is a decimal number, okay? So you can actually convert with a base 10. So if you convert it with a base 10, what is the value of I it is going to show? I is going to be 101 only. 101 decimal number, it takes as it is. And if you do not specify anything in integer, then also it's going to show 101, which means that by default integer command is going to assume that the string you have specified has base 10. If it is something else, you have to specify that base. For instance, if I specify 8, this becomes an octal number. The corresponding integer value is 65. Let us cross check it. Let's take octal. Okay, 101 in octal corresponds to decimal 65. Okay, so this is how we can convert everything. Let's summarize. We can display a string, we can create a string with multiple variables with number 0, 1, 2, so and so. Use dot format and specify the variable names one after the other. You can, on the other hand, choose a static you can on the other hand choose a specific variable name, and in the format keep on assigning their value. It's not required that your variable has to be assigned with a variable only. You can specify a static value also. So even if I do that, you're going to 10 and 20, let's specify 30. So it's not required that in the format operator you only have to specify the variables. You can specify the constant number also. Instead of C, I have passed 30, so it's going to take 30. Now, we have also learned that in the format with colon, whenever you specify something, that becomes the general format. By default, everything that is displayed through a string gets left alignment. By specifying a string with greater than sign, you can make the string as right alignment string. Make the string as right alignment string. You can specify the alignment of the formatting option also in a curly braces as a variable. Now, we also learned that if a string is represented, if you have a number, you can present a real number either as exponential by specifying it as with colon E format, which will present it as an exponential, or you can specify that number with a colon G format, which will be printing it as a general number format. If you do not specify anything, by default it's going to be general format. Then we learned that if you have a string which is representing a real number, float, you cannot directly convert that into an integer type. You have to first convert it into a float, and then that float you can convert it into integer. Float can be converted, float can be used in two ways. Either you can round off or you can use the ceiling option. In the for both rounding off and ceiling, you need to take the help of a mathematical package, for example numpy. So using numpy's round operation, you can round off a specific number into certain spaces of the string. If you use the ceil operation, it is going to be the next higher number if after decimal the value is greater than 0.5. We can also specify, we can also convert any specific number into integer type just by specifying their base. Their base can be specified as 2, 8, 10 and 16 common numbers, base 2, octal numbers, base 8, hexadecimal number, base 16, decimal number, base 10. If you do not specify any base, by default the considered number is going to be a decimal number. We also learned that rounding off or ceiling is not a very good or very good design option, because it may compromise on the precision. However, At the time of displaying such a big number may reduce the visibility. So you can use again the strings formatting option with 0.2f, 0.3f, 0.4f to specify up to what decimal places you want to display the value. Up to that decimal places is going to be intact. Rest, whatever it has got, it is going to be either presented as it is or it's going to be incremented by 1 based on whether that value is greater than 0.5 or not.